Good afternoon. I am here with you today to discuss a topic on the different cations and anions as well. But for the first part of our discussion, we have to focus more on the cations, or these are just simply some of the group elements in the periodic table. So how are the group elements in the periodic table be classified? They could be classified according to their nature as a metal. So we have the elements that are considered as metal. In the periodic table that is shown to you, they are reflected as those with blue colors. And then we have also those with yellow, and they are the nonmetals. In between them are actually the metalloids. So you have the metals for the blue and then followed by the non-metals, which are the ones in yellow, and the ones in green is or are the metalloids. So the periodic table presents you the chemical and physical property of elements, and these are based also on periodic activities or functions, and one of them is according to their atomic masses. The chemical properties and physical properties of elements can also be classified according to the atom number. So, the atomic number increases from 1 up to the last. This is the same with the atomic mass. It starts with the very light mass of hydrogen then going out. Another thing that we should remember about the periodic table is that the elements are arranged in groups, that is by column, and then each column possesses similar or related chemical and physical properties. The elements can be arranged in periods or rows that possess progressive different physical and chemical properties. So the columns or the one in standing position are called the columns. So the one in vertical position or lying position are actually the rows or the periods. So the groups are in columns, the periods are in rows. Okay, here are the 8 groups that you could meet in the periodic table. You have the alkali metals, the alkali earth metals, and then you have the boron family, the carbon family, the nitrogen family. And then for group 7 and 6, you have the chalcogens and the halogens. And the last column is actually the noble gases. So that is how they are arranged. Now, related to the periodic table are actually the valences. What are valence? Valence is the number of chemical bond an atom can form. So the number of the valence that it could share defines what kind of atomic bond that that element could combine with. Carbon needs 4 electrons to reach stable octet configuration or to reach 8 shared electrons. Therefore, the valency of carbon is 4. So to complete the 8, it will be shared by other elements. Chlorine belongs to group 7. So since it belongs to group 7, chlorine has the valence of negative 1. Why negative 1? Because it is higher, it is higher than 4, and it is found in uh, the group 8. So 8 minus 7 is equal to 1. If the group is beyond 4, the most probable valence is determined by subtracting the group number with 8. So since chlorine belongs to group 7, following the octet rule, that is 8, so 8 minus 7, or sorry, 7 minus 8 is equal to negative 1. Hence, the valence 1. Carbon belongs to group 4. Carbon has two valences. You have the 4 and the 2. The 4 as a valence is a result from 8 minus the group number 4, that is 4. Lithium has atomic number of 3. Lithium belongs to row 2. So lithium atom belongs to group 1. So the number of valence is defines also or could define also as to what group does that elements belongs to. Just like the illustration on the case of lithium. So lithium has 3 electrons. Lithium atom has 2 shells. Hence, lithium has the valence of 1. Valence electrons are the electrons in the outermost shell of an electron. So, in the illustration, the valence electron for lithium is 1. For neutral atoms, the number of valence of electron is equal to the atom's main group number. Hence, the number of valence electron is equal to the major group number of a neutral atom. So for hydrogen, it belongs to group 1, the valence is 1. For charged atom, there is a deviation from the normal number of valence electrons. The charge of an atom tells you how much deviation there is from element's normal valence number. Electrons are negatively charged, just like for the case of the halides. The halides, fluorine, chlorine, bromine, iodine belongs to group 7. Following the octet rule, 7 minus 8 will give negative 2. So, the electrons are in negative condition also. Negatively charged atom means that there are more electrons than the normal valence number. Positively charged atom has fewer electrons than the normal valence electron. So, if we're going to lay this into an equation, the number of valence electrons is equal to the main group number minus the charge. Calcium belongs to group 2 as a cation that is plus 2 has 0 valence electron. Calcium normally has 2 valence electron, but with the charge 2, it is missing 2 electrons. So 2 or 2 as positive 2 minus the number of the group that makes it 0. Then fluorine, negative 1, has 8 valence electron. Negative 1, negative 1 minus negative 7, that will give positive 8. So that is 8 valence electron. So, if you are into the higher than 4 groups, a group number, you have to add the negative charge with negative 8, making the valence electron neutral. Valence electrons, the electrons which are poles from the positive nucleus and most closely held. So, the electrons determine the chemical property of elements or the molecules. So, as illustrated, neutral atom and atomic number and number of proton in the nucleus of an atom increases. So if you're going to look at group 1, 2, 3, 4, 5, 6, 7, 8, the atomic number increases as the group number increases. The number of proton increases as the group number also increases. The same true with its nucleus. So as the number of group number increases, the size of the nucleus of an atom also increases. These are graphical illustration as to how each group possess its atomic size or atomic radius. If you're going to look at your periodic table, lithium, sodium, potassium, Rb, and cesium, all of these belong to group 1. And they have the tallest, biggest atomic radius. Now, if you're going to look at each of these 8, the smallest radius goes to fluorine, chlorine, bromine, iodine. And where are these in the periodic table? They are found in group 7, or they are your halogen. So, as the atomic number or as the atomic radius increases, the atomic number also increases. Hence, as the atomic number increases, the atomic radius decreases. This is group 1. This is group 7. And the atomic radius here is shown by the increasing arrow. And the atomic radius here is also increasing. So, lithium, sodium, potassium, rubidium, in their own group, they have the biggest, or they have the shortest atomic number. But they have the biggest atomic radius. So, in this case, fluorine has the greatest atomic number in group 1, but it has the smallest atomic radius. I have discussed this already. Going further to the table by groups, the blue here are earth metals. These are the alkali earth metals or alkali metals. This is the alkaline earth metals. And then if we go to group 3, you have here the non-metals. Except that in this case, they are more specific to be the halogens. And in the group A, of course, you have the noble gases. If we're going to look at the table by size of atoms, you will notice that as you go further to the periodic table, as you go higher in terms of group, the atomic size decreases. Okay, the table by electron affinity. So, in terms of electron affinity or electronegativity, you will see that in group 1, lithium belongs to 1 or has the electronegativity of 1.0 to 1.9. So it follows the transition between beryllium, magnesium, aluminum, silicon, calcium, gallium, and indium. Now, if you're going to look at how they are positioned, lithium has an electronegativity of 1 only, but as compared with the remaining elements, it has 0.99 or lower than 1. So, as implied, as you go from the lowest group number to the highest group number, the electronegativity increases. This could be seen in group 1, group 2, but there are some instances whereby the electronegativity of 2 is abnormally distributed in the higher groups. Okay, let us try to discuss the cations one by one. In your inorganic chemistry, we have discussed already what is hydrogen, but this is just a review. Hydrogen has a very simple structure that is, it has only one electron, and also the atomic weight is near to 1. Hydrogen is the most abundant gas or the most abundant element in the universe. It could play between organic and inorganic metals and nonmetals. Hydrogen is abundant in combination, especially with the case of oxygen, wherein hydrogen and oxygen forms the, the biggest volume of our planet, that is water. Okay, where does hydrogen belongs to? That is still a question. But established periodic table will say that it belongs to group 1. But its property, chemical property and other physical property are not usually not the same with group 1. Like group 1A elements, hydrogen has an outer electron configuration of S1, has a single valence electron, and of course has plus 1 oxidation number or state. Unlike the alkaline metals, hydrogen shares electrons with nonmetals. And hydrogen has a much higher ionization energy than any alkaline metals because of its size. Like group 4A, hydrogen has a half-filled valence electron. Hydrogen is similar to other group 4A elements in terms of ionization energy, electron affinity, electronegativity, and bond energy, as we have discussed just a few minutes ago. Like the halogens of group 7A, hydrogen exists as a diatomic molecule. So all members of group A, they are expressed as H2 or diatomic molecule at free state. And it only needs one electron to fill its valence shell. But unlike halogens, hydrogen has a much lower electronegativity. And hydrogen lacks the 3-valence electron pair that halogen have. Okay, these are the highlights or had made hydrogen popular in chemistry because they could work as ionic hydrides when hydrogen reacts with reactive metals. So you have the white crystalline hydrides of lithium and calcium for various commercial purposes. And then they are also capable of working with covalent bonding. So hydrides in the form of covalent or molecular could be formed or enjoyed by hydrogen. Many transition metals form metallic hydrides, in which hydrogen 2 molecules or binary hydrogen molecules occupy the halls of crystal structure of the metal.